be all right. All right, here we go. Let's try this one more time. We had to restart it. So here we go. So here we go. We finished up talking about trapezoids. That was the last thing we talked about. Specifically, give it to me. 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 All right, now sit down and pay attention. I'm not going to read the note. If I read the note, I'm going to give you an SLD, or it's not SLD anymore. We used to have SLD, silent love detention. I'll give you an ASD. That's ASL. It's not ASD. All right, here we go. Oh, my goodness. This class is out of control. All right, so we talked about isosceles trapezoid. And then, so what we're going to do now is we're going to do an example 2. So here we go. They give you a kite. So I'm just going to freehand this. I'm not going to be, I know we didn't do an example of a kite. So we're going to do an example. What? Trying to do something here. What's that? A broom. I have no idea if I have it. All right, here we go. It's not the most perfect kite, but it's a kite. Looks good to me too. All right, so here we go. This is an example. You could see this on a quiz or on a test. So I would take notes on this. I would write it down. I would pay attention to this right here. Really, the part about the kite is not the difficult part. It's the algebra is the part that we really want to concentrate on here. So this side right here, they don't just say it's 3. They say it's this. It's 3 times y plus 2. You've seen this a lot in this class. You'll see it a lot the rest of the year. This is why it's so important to learn your algebra, because you're going to use it all the time. Okay. All right, so this is a kite. How do you know it's a kite? Because these 2 consecutive sides right here are equal, and these 2 consecutive sides right here are equal to each other. So really, you really don't even have to know anything about a kite. As long as you know that little tick mark, and that little tick mark means they're equal, and this one right here and this one right here means they're equal, you could find this, you could do this problem, okay? So what do you think we're going to do? If these 2 sides are equal, what are we going to do to these 2 right here? Give it to me. Give it to me. Come on, give it to me. Yes. No. Walk up here. If you do anything else but give it to me, I'm going to write you up, I promise you. Okay. Here we go. So look, what's true about these 2 things right here? This thing here and this thing here. They're equal to each other. So what are you going to do? Set them equal to each other. Exactly right. So it's as easy as that. Well, it's not as easy as that because you got to do the math, but doing the math isn't really a big deal. Yeah, I think it is. So here's something we really haven't, I don't know if we've done this year or not, but you did this in algebra. You did this like hundreds of times in algebra, didn't you? You had a 3 outside of this parentheses right here. What do you do with that 3? You distribute. Good. Glad you used the right word. You distribute it. Okay, so let's go ahead and distribute. That means we multiply that 3 by everything in this parentheses. So what do you get? You get 3y plus 6. There's nothing you can do over here on the right side, so I'm just going to write that down. Everybody getting this down?
Yes, sir.
So really, the geometry was not the hard part of this. The geometry was super easy. Okay, the geometry was just noticing that these are equal to each other, and then you just set them equal to each other. Yeah, it's the algebra. That's a little bit of work. All right, so I could take the 5y to the left, or I could take the 3y to the right. Which one would you do? I would take the one to the right, okay? Just why would I do that? Because it'll keep it positive, exactly right, okay? A lot of people just like to always put the variable on the left. It doesn't matter if it comes out positive or negative, but I kind of like just to keep it positive. I think it just makes it a little bit easier. So I'm going to put the y's on the right, then I'm going to take this 2, and I'm going to subtract a 2 and put it on the left. See what I'm trying to do? Put all the y's on the right, and then I'm going to take the regular numbers. We call them constants, by the way, like a regular number. We call it a constant, and I'm going to put that over to the left. So what happens here? The 3 y's add up to 0, so we got to do this. Positive 6 minus 2 is 4, and this cancels out. This is what? 2y. And then that's super easy now. Just divide both sides by 2. And now you can just write y on the left-hand side. Y is equal to what? 2. But the question, I didn't write the question down. I should have. But the question says, find the measures of the sides of the triangle. So just finding what y is equal to, is that enough?
We can find the answer now.
We got to plug it in. Right. We got to figure out what the length of this side is. You should be able to put it into either one of these, and they should come out exactly the same. If it doesn't, well, you did something wrong, okay? You either checked it wrong, you put it in wrong, or you did the algebra wrong. So what did we say y was, by the way? Wasn't it 2? Okay. So I'll just put it up here so we can see it. So you could put 2 in for this one. Let's just do it in our head. Put a 2 in for this y right here. So 2 plus 2 is 4 times 3 is 12. So that side should be 12. Let's do it over here just to make sure we did it right, okay? Put the 2 in for the y here. 5 times 2 is 10 plus 2 is 12. And it works, doesn't it? Did you have to put it in both of them? Nope. You could have put it in for either one of them. And if you know that one's 12, the other one's got to be 12 as well. So on a quiz or a test, okay, don't waste your time putting into both of them. Just put it into one of them, okay? And then you know the other one's the same, so just write down that answer. Everybody got that? Does that help you solve for these two sides? No. What do we have to do here? We got to set them equal to each other. So let's do that a little faster. So it's 3x minus 1 equals x plus 5. This is just a little bit easier. Subtract an x from both sides. Just in your head, what will you get? If I subtract an x from that? 2 what? 2x, okay? Add a 1 to both sides. What are you going to get in your head? Going to get a 6, okay? Divide by 2 in your head, both sides. X is what? 3. Is that your answer? Do you circle it? No. Got to put it in because we're trying to find the lengths of the sides. Put a 3 in for this. What do you get? How about 8? It's 3 plus 5, guys. Okay, all right? 3 plus 5 is 8. Now, what should this side right here be? Should be the same, okay? Just for fun, let's put it in and see if it really is. So let's take that 3 and put it in for this. 3 times 3 is 9, minus 1 is 8. Sure enough. So what are my sides? 12 and 12, 8 and 8. And that's a kite. Pretty simple, isn't it? Yeah. All right. Let's move on. Let's do, wow, they give you another example. Now this one's a little more difficult. It's going to go back to some stuff that we learned. I'll tell you what, let's do this. I'm going to grab, yeah, we'll grab this. Remember doing these coordinates, right? X and Y and all that stuff. Remember the distance formula, midpoint formula, the slopes and all that stuff? Okay, it's coming back. There it is. Let's, we'll make it a little bit bigger so we can see it. I'll put it over to the side. I'll do some work over here. So here's what they give you. They give you some points. So let's change the color so I can see them a little bit better. I think we can see that pink pretty good on the screen. So the first point they give you is negative 3, 0. So I'm going to plot negative 3, 0. Where is that? 1, 2, 3, 0. So that's our first point. Okay, that's point R, by the way. We'll put the letters in there in a minute. Okay, then they give you another point is negative 1, 3. So let's plot that. So we start at the origin, we go negative 1 in the x, and we go 3 up. 1, 2, 3, right there. Pretty easy, right? The other one is 2, 1. So if I plot the point 2, 1, start in the middle at the origin, okay, and then go 2, 1. So I go to the right 2 and go up what? 1. So that's that right there. And then the last point they give you is 0, negative 2. So you don't go anywhere on the x, and you go down 2, you go right there. Okay? And now what we're going to do is we're going to connect them. And it's going to make a quadrilateral. And what we have to do a little bit of math, and you're exactly right. We got to figure out what kind of quadrilateral is this. Not just by guessing, okay? Because you could probably look at this and guess and figure out what it is. Okay, what would your guess be if you were to guess? Looks like a square, doesn't it? Okay. But I have to show that this is actually a square. So in order to be a square, what do you think are some things that you need to know about this thing right here, if it's a square? Okay, 4 90-degree angles, that's good. And what else? Okay, parallel lines. These opposite sides are parallel. What else is important? The 90-degree angles is super important. What's really important about it other than that? All sides are equal, okay? Okay, all four of these sides should be equal to each other. So guess what we're going to do? We're going to find if all four sides are actually equal to each other, okay? So let's do that. But before we do that, let's put some letters in here. This is R, this is S, this one is T, and this one is U, all right? And I'll tell you what, let's come up here and let's just put the points on here. It'll make it a little easier when we do this thing. We're going to do the distance formula. Do you remember the distance formula? Do you remember at least doing it? All right, you're going to have a lot of practice on this one, okay? Because we're going to do it. How many times are we going to do it? How many? Give me an exact number. 4 times, because I want to find the length of all 4 sides, okay? So we're going to do the distance formula 4 times. But let's write the points down. What was R? 1, 2, 3. It was -3, 0. And then S was what? -1, 1, 2, 3. And then T is what? 2, 1. And then U is 0, -2. Did I get all these right? I think I did. All right, so that's just is a little helpful just to have them all listed right here. It just makes it a little easier, okay? So where do you want to start? Let's start at RS. Let's find the distance, okay? So we are finding the distance. So we're going to use a distance formula. Let me just write the distance formula down once, and then we'll just use it 4 times, okay? Do you remember what the distance formula is? What's the main thing about the distance formula? You got a big old what? Yeah, but big old square root, right? Remember this? Okay, write it down if you don't remember it. It wasn't that long ago we did this. It wasn't last chapter, right? Maybe the chapter before. Okay. 2 chapters before. Okay. But we did a lot of this. So those are squared. Now, how do we find out what goes in the first one? What do? Take the what? X's and just subtract the X's. Again, it doesn't matter what order you subtract them. I could have gone x2 minus x1 if I wanted to. It doesn't make any difference. All right? And it really, tell you the truth, it doesn't matter if you did the y's here first and the x's here first. We're just going to add them up anyway, right? So, but this is how we usually write it. And then I'm going to take the y's and I'm going to subtract them. So that's my formula. Little review. It's been a little while since we've done it, but that's it right there. I should be writing in white. That'd be a lot easier to see, wouldn't it? All right, so let's do RS. Let's find the distance of RS. Okay? Everybody watching and writing? Nico, do you even have a pencil? Well, use it. So RS, let's do the distance. So I write down the little shell, as we said. All right, and let's subtract the x's from each other. So RS, it's these first 2 right here. Let's subtract the x's. The first part of the ordered pair is the x. So it's -3 minus what? It's not 1, it's a -1. So it's minus -1. Let's do the x's on RS. Which one are the x's? It's the 0 and the 3. So I subtract those. 0 minus 3. And now we just do some math and we figure out what this is equal to. We can do a little bit in our head at this point. Minus a negative, add a line, change the sign, right? -3 plus 1 is -2. What if you square -2? What do you get? You get a 4, right? -2 times -2 is 4. So that stuff right there is a 4. Plus, what about this? What's 0 minus 3? It's just -3. What if you square a -3? It's -3 times -3. What is -3 times -3? It's positive 9, correct? Okay, add these up. What do you get? 13. Put it under a square root, and that's how long this RS is. We're not going to put it in a calculator. We're not going to get a decimal. Okay, we're just going to keep it square to 13. Now, if this truly is a square, like it looks like, what do you think the other sides are going to come out to be? Square root of 13. They should. Okay, if they don't, it's either not a square or you did something wrong. Okay.
Did you square 4?
Yeah, I squared 2 because -3 plus 1 is -2. Right? I didn't do it. I just did it in my head. Well, see, it's -2 squared. Yep, that's the 4 right here. That's -3, but the whole thing is squared. If you square a negative, it's positive, and that's 9. Everybody good? All right, now let's do the rest. Let's go a lot faster, though. All right? And some of you are thinking, you went too fast for me already.
You're not going fast enough.
Is that right? I'm probably not. Oops. What's going on there? All right, so ST, where's ST? It's these two middle ones right here. Let's subtract the x's, -1 minus 2. -1 minus 2. Let's subtract the y's, 3 minus 1. After we do these, after the fourth time we've done these, you'll see that it's not too hard. What's -1 minus 2? Add a line, change the sign. That's -3. What's -3 squared? 9. We did it up here, right? So far, so good, right? What about this? 3 minus 1. That's 2. What's 2 squared? It's 4. What do we get? Square root of 13. So far, this is the square root of 13, and this one's the square root of 13. Is that enough just to say those two are equal? Does that automatically make the other ones equal? No. So we got to do it some more, all right? Tell you what, you don't erase it, but I'm going to erase this just because I'm running out of room. Is that all right? Let's do this one, TU. So it's these last two right here. So TU, let's plug it in here. Right? After you've done the other ones, the rest should be pretty easy. T and U. What do? Subtract the x's from each other. That's 2 minus 0. Subtract the y's from each other. That's 1 minus -2. It's important that you understand that that's not just a 2, it's a -2, and you are subtracting it. Okay? Here we go. 2 minus 0 is 2. Squared is 4. Look familiar? What about this? What's 1 minus -2? Add a line, change the sign. It's 1 plus 2, which is 3. 3 squared is 9. Check it out. It's square root of 13. So this is the square root of 13. All right? Let's do it one more time. All right? We can go as fast as we can write now, probably. You think so? I don't think so. RU, it's the first one over here and the last one right here. So let's subtract the x's. It's -3 minus 0. And let's subtract the y's. It's 0 minus -2. Guess what happens? This is -3 squared is 9. This is +2 squared, which is 4. And lo and behold, we get the square root of 13. Just knowing that all four sides are equal, does that automatically make it a square? No, it doesn't. It makes it a what? Yeah, well, it's a quadrilateral because it's got four sides, not because the sides are all equal. Parallelograms, it's not necessarily a parallelogram because all four sides are equal. It's a rhombus. It's a rhombus. Remember, the definition of a rhombus says it's a quadrilateral, four sides, that has all four sides equal to each other. Everybody with me? Okay, so far it's a rhombus, but I'm trying to show that it's a square. So what was the first thing you guys said about a square? What must be true about a square? Well, we got that already. What was the other thing? Yeah, 90 degrees, okay? All right, so all four of these angles have to be 90 degrees. How in the world am I going to show these 90-degree angles? Well, let me give you a little hint. What if you had, I'll make it go straight across. What if you had like this and like this? Okay, if this is 90 degrees, what's true about those two lines? Give me a good geometry word. What's true about both of these lines if it's 90 degrees? I heard it. Who said it? It's perpendicular, okay? It's perpendicular, okay? Everybody remember that word, right? We've used it a ton. Let me get rid of all this mess. So, with that said, what do we know when we did this stuff right here? What do we know about stuff for two lines to be perpendicular? We talk about the slopes. Remember that? What would we say must be true about the slopes? So M1 must be equal to, do you remember this? No. 1 over M2. Does anybody remember this? Okay, I'll give you a word. You'll probably remember this. Forgot the negative right there. They're negative reciprocals of each other. Actually, I should have put a 1 here instead of a 2. Boom, right there. Seriously? So watch. So if I have a slope of a line that's 1/3, what is the slope of a line that's perpendicular to the slope of this line? It's negative reciprocal. We've done this. What's the reciprocal of 1 over 3? What's the reciprocal of 1 over 3? It's 3. 3 over 1. What's the negative, or what's the opposite sign of this? So if you have a line with a slope of 1/3 and you have a line with a slope of -3, they're going to be perpendicular, which means they form what kind of an angle? A right angle. Okay, let me give you another one. What if I said you had a slope of a line that's -5/7? What would the slope of a line be that's perpendicular to this line? It'd be positive 7/5. Okay, everybody see that? That's pretty easy, isn't it? Just flip it, change the sign. You with me? And what do we find? These are the what? They're the slopes. Okay, they're the slopes. So what we're going to do is this. We're going to find the slopes. Oh, I shouldn't have. Let's do this. Boom, 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 boom. I should have kept those points up there. Yeah. So let's just get rid of this. I'll keep those points there so I don't have to rewrite them again. All right. So what we're going to do is we're going to find the slopes. I want to find the slope of RS and the slope of ST. Okay. Everybody watching? So if I find the slope of RS and I find the slope of ST, if their slopes are negative reciprocals of each other, then what's true about those two lines? They are perpendicular. Okay? So let's find the slope of RS. So the slope of RS. We'll put a little RS right there. Misses. All right? The slope of RS. So how do we find the slope? Subtract the y's, put it on the top, and then what? Subtract. Can't see that color? All right, I'll change colors. Whoops, thought I changed it. Let's try it again. There we go. Okay. Can you see that better? Okay. So watch. What is the slope of RS? What do? We subtract the y's from each other with R and S. So what are we subtracting? 0 minus 3. Now on the bottom, we subtract the x's from each other. What are the x's in R and S? It's -3 minus -1. So what's the slope of RS? It's -3 over, what do we do here? Add a line, change the sign. That's -2. What's negative over negative? It's positive 3 over 2. So the slope of RS, this one right here, is 3 over 2. Let's find the slope of ST. So let's find the slope of ST. Do the same thing, but we're doing it with S and T. Subtract the y's from each other. That's 3 minus 1. Subtract the x's from each other. That's -1 minus 2. Let's see what we get here. So what's 3 minus 1? It's 2. What's -1 minus 2? It's -3. Now check this out. Watch. This is why we're doing this. Look at this slope and look at this slope. Compare them. Are they negative reciprocals of each other? Yeah, because look, you got 3 halves. What's the reciprocal of 3 halves? 2/3. This is positive, so this one's negative. Are they negative reciprocals? Yes. So what does that mean about this angle right here? That means it's 90 degrees because the two lines are perpendicular. If the lines are perpendicular, then they make a 90-degree angle. Got a lot of people checked out on me on this one. All right? You got to stay awake. Got to stay with me. Write this stuff down, okay? Just at least write it down. You could always go back, watch this part of the video, okay, if you are nodding off in here. All right? So that's super important. So now what we're going to do, I'm running out of time, but what we're going to do, we found the slope of this one, found the slope of this. What do you think the slope of this one's going to be? It's going to be the same thing as RS, isn't it? So that's going to be 3 halves. What do you think the slope of this one's going to be? It's -2/3. I'm not going to do the work, but you should do the work, and you will see that these are perpendicular, so are these two, so are these two, so are these two. So we just kind of proved, well, it's not really a proof, but we showed that all 4 sides are equal and all 4 angles are right angles. Okay? That means, what is this thing then? It's a what? It's a square. Okay? So we found out that that thing is a square. All right. That's a good place to stop. So what I'm going to do, I'm revising the lesson plans a little bit. I know it's only Tuesday, but so what I have you do 1 to 18. So finish up 1 to 18. I think you should be able to do all of 1 to 18, okay? And then we'll go on to something else. Still the same section, but we'll do a little bit more.